Hi, welcome back. Rashid here with another video. And today we are going to look into multi-cycle exceptions. Yeah, that's a very important one. And yeah, most likely in interviews, one or more questions come from this one. So the exception I'm now right now thinking, okay, in the next video or so, I'll give you some overview of exception. But let's be specific right now. What I'm talking about right now here. Um, let's start focus on this picture. Okay, we did it yesterday, and this is a timing path from slow to fast clock. We already looked at yesterday. Remember, what is the setup edge? Launch. This is a launch. This is a capture clock, right? Slow to fast. So launch starts here on the rise edge of the clock, and capture. Remember that this is kind of within this cycle. Tool looks for the worst edge. This is one edge and this is another edge. So tool picks this is this edge from this. So 0 to 10. So it's a slow clock, which is so it's a 50 megahertz to 100 megahertz clock, but the single cycle appears as 100 megahertz, not 50 megahertz. And what is hold? Hold is from to here to here. So let's say you have this single cycle path. So prime time or tempos they report like a 10 required time is 10 nanosecond. But the designers, RTL folks, they coded the logic such that when it's launched here, they expect that there's a huge logic. Let's say it has adders, multipliers, a lot of things in the data path, and they expect that this logic, the valid value can be obtained after two cycles of the fast clock or one edge cycle of the slow clock. So even though tool is going to show you a violation here, but again, when you so this also brings an important discussion. I think there was a question, okay, if there is a timing violation, how to fix that? So very first of all, if your violation is, let's say in the case of 10 nanosecond, if it's violating by 500 picoseconds, 600 picos, 700 picosecond, right? Then you think, okay, I need to look into the path. Okay, we can make some improvements. Going back to synthesis, maybe create path groups, maybe tighten things, select routing on higher layers, use cells with high drive strength. So you can change the knobs in the synthesis and place and route tools so that tool actually optimize this path. A typical reason for not tool optimizing is because tool typically works on the worst path in each path group. There is a critical range you can mention for each path group. Then tool, if it's not able to fix the top path, it's going to move to the second one and then so on. So the very first thing that you want to make sure that tool actually worked on it. If tool has worked on it and it has explored all the possible options and still is not fixed, okay, there's not fixed because there could be some other constraint. If it compromises more, it makes some bad impact on something else, then that's it. That's really 3, 4, 500 picosecond less than, so your frequency probably 80 megahertz, 90 megahertz, something like that, the highest frequency that you can run, right? But this path is going to violate by how much? If let's say the designer, then they coded RTL, they had 20 nanosecond in mind, right? This whole cycle. But our violation will be it will be at least 10 nanosecond, right? At least one whole cycle. So 10 nanosecond when you see a violation, that means there's something wrong, right? There's no way tool can fix that much. So that's where you need to talk to RTL guys. Okay, guys, we have a 10 nanosecond violation. Tool is seeing this violation, but it's not fixing. And it's crazy. It's like 2 times the period of this. And most likely they will tell you, okay, no, hold on. We actually designed this logic to be captured in 20 nanoseconds, like 2 cycles of the fast clock, 1 cycle of the slow clock. Or you say, oh, I see. Now you need to adjust from 0 to 20. Your capture clock is still 6 clock, but you got an exception from RTL guys. Hey, you can give yourself 2 cycles for a setup. Okay, that's great. So that's where you write this constraints. Set underscore multicycle path, you say from this clock to this clock. Now keep in mind, generally this exception when you write, you have to be very specific. This is a very broad one right now, because from any flop to any other flop, as long as launch flop is on this clock, capture is on this clock, you are putting this exception. This exception right now is not very module specific, component specific, register specific. Typically what you say, even when you from to, you say through certain pins, through certain logic. You can mention several throughs. Okay, so generally if I write it, I want to be, if on a particular logic, then I want to involve dash through on it. But this is for explanation purpose. So I'm going to use from clock to clock. And I am mentioning setup to 2 cycles. So after I apply this, and I do update timing, the new timing setup is, when you do setup, it will be from here, rise here to 20 nanosecond, 2 cycle later. Tool is going, required time will be 20 nanosecond. And now path most likely going to meet timing. Okay, but what about hold? Here hold was 0 to 0, which made sense, because whatever you launch here, you want to make sure it's not captured right here. As soon as you move setup edge, hold edge, typically a cycle before that, hold edge by default moves. Okay, now that's a problem. What does that mean? Means that this data needs to be held under all circumstances this long enough for 10 nanoseconds. So this path delay cannot be less than 10 nanoseconds. Setup cannot be 20 nanoseconds. Now if that condition you meet, that's fine. But that's a pretty long time, right? Sometimes there are some short paths from this start point to some other endpoints, still on this clock. So you talk to the designer, hey, he said, no, I'm not worried. I'm just going to make sure that I'm not capturing on this clock. So even if some data is available, I just made sure by design, by putting a clock, or I just ignore whatever data is here. I just make sure I capture only on this one. So don't worry about this one. So in that case, your problem is 0 to 0 or here to here, right? So typically whenever we use setup to, you just don't write just setup. That's a typical problem or typical mistake newcomers make. So you need to always mention a hold 1. Okay, and so setup whenever a 2, hold is always -1. Okay, but you put this hold. So your hold will be something like this. You start here, okay, and what is your hold? You give yourself a cycle later on. So hold on. Okay, I think I know what I'm doing. I'm giving you. So when you do this, so what is going to do tool? Tool has moved with this one, this edge, starting edge, but without mentioning anything additional, it has moved this edge to this one. So in a way, it has moved the start point. So default on here, you didn't mention anything, but default is always the ses end one is moved. But hold, the default is start. So it moves, you said hold is 1, it moved this one to this one, edge came in. So for hold, in order to have 0 to 0, you need to mention this dash end. Okay, once you mention this dash end, now it says that, okay, don't do this, but actually this end one, I want to move this back. So now this is your valid one. This is not a valid one, right? We ensure we don't capture it here. This is the problem. And this is the problem. Okay, makes sense. So the tricky part is both. You need to two things. You need to make sure you give a hold one, but also you need to make sure you put a dash end. The end edge needs to be moved. Okay, so yeah, let's finish it here. And the next time we will look into fast to slow, and there are some tricky stuff there too. So which we will look into in the next video. All right, thank you so much. Take care. Bye.